Hello there. How are you? I hope you guys are doing well. So today let's start with something new. All right. So today I'm going to touch with the radicals. Here I'll try to cover all the sections of the radicals, including its properties, plus rationalization, and I will close with the graphs because plotting the graphs in the radicals has become quite a job. Okay. So today I will start with is the definition. I generally don't uh, spend my time in the definition business, but uh, I want to discuss something important. Okay. So if I give you the nth root of the A, any number A is represented by B, or which means B raised to n is equal to A. Now B raised to n is equal to A. Now here, if you see here, this guy is index. Okay, this is called as a radical. The entire thing is called as a radical, and this guy is called as a radicand. Okay. Now, to master the skills in the radicals, you have to know two things must. Here, one is the index, and second thing is the negative sign. Okay. So if you look, what is the index? And if you look for the negative sign, whether it is sitting inside the radical here or here, that matters. If it is sitting outside the radical, you are safe. If it is sitting inside the radical, things becomes a little bit complicated. All right, so let's get back to the business. Okay. Now, if I give you as an example of square root of 25, okay, uh, the answer is plus minus 5, right? Answer is plus minus 5. In other words, what I'm asking you is that, hey guys, can you find a number when I square that number? When I square that number, I will end up with this. Okay, so immediately the obvious choice is that 5 times 5 is 25, and negative 5 times negative 5 is 25. And same story. Okay, so if I give you 36, you will give me plus minus 6. If I give you 144, you will give me plus minus 12. Okay, so what we learned here. Okay, so when there is no index, when there is no index, so by default index is by default index is 2. Okay, so that we don't have to tell people. Okay, so when I say the square root of something, you know this one. But the real problem comes into picture is that when we are going to solve square root of 48, okay, square root of 94, then if I want to find out a square root, fourth root of 81, okay. So that kind of a problems, of course, I'm going to solve this one. But before that, let's check this one. So I know that index is 2, and luckily there is no negative sign, so I'm safe here with the answer over here. Okay. Another example, if I want to give it to you, if I give you square root of the cube root of 64. Okay. So the answer is 4. Why? Why? Because I want to try. I'm focusing on this index 3. Okay, and this index is telling me that, okay, so if I want to find out the number whose cube, when I make a cube, I should land up with this guy. Okay, and obviously it is 4. Now uh, let's solve some initial problems, and then I will take you to the something difficult. Okay. So if I give you, I've already give you this one. So cube root of 125. Okay. Two. See the examples here. So cube root of 16. What root is this? fifth root of 32, and I will close with something interesting, which is 827. Okay, so let's solve. The first example, as I told you, look at the index. Look at the index. It is 3. So I have to find a number. When I cube that number, I should land up here. And the obvious choice is 5, because you know that 5 times 5 times 5 is 125. Now here, try to find out the number. When I fourth times, it should give me the 16. And obviously choice is 2. Here, fifth root of 32 is again 2. And here, of course, I'm going to solve this with the property as well. I'm going to discuss that down the road. But right now, what I will do is something like this. Okay. And obviously, cube root of 8 is 2, and cube root of 27 is 3. Okay, so this is the basic idea. This is the very, very basic idea of the radicals. I'll take you towards the next part. Now, if I give you, okay, square root of 100, purposely I'll give you the same example, square root of 100, okay, then square root of negative 100, fourth is fourth root of 81, fifth, fourth root of negative 81, and I would like you to give it a try. So if you see here, if I start solving these examples, I know that obviously the square root of 100 is 10. The square root of 100, if you see here, the negative sign is sitting outside the radical. Okay, so how I'm going to write is the square root of 100 is 10, but obviously the negative sign is sitting outside, so it's a negative 10. Let's solve this afterwards. Fourth one, the fourth root of 81 is obviously 3. All right, so what is the answer here is that it does not exist. Not possible. Okay, why? Because if you see here, the index is 2, the index is 2, and the negative sign is inserted inside the radical. So I do not have any number. I do not have any number. When I square that number, I will land up with negative 100. Okay, and of course, this is not a solution as far as algebra 1 is concerned, but when we will do with algebra 2 complex numbers, I will tell you how to solve this. So this is the peculiar things. Now let's go to the the fifth one, and the fifth one lies on the same line. The fourth root, I'm trying to find out the fourth root of negative 81, and again, this one does not exist. To add the interesting thing, if I say that cube root of negative 8, but the cube root of negative 8 is negative 2, okay? The why? Because if you if you find out a number whose cube is, if I make that number the cube, I should land up with negative 8. So if you see here, negative 2 times negative 2 times negative 2, and which is negative 8, and condition is satisfied. So what you learn from this lesson is that when you are dealing with the radicals, the two things you should be worried about is the index and the negative sign. So long story short, if the index is even, if the index is even and the negative sign is inside, the negative sign is inside the radical, solution, you have no solution. If the index is odd, and it doesn't matter if the negative sign is inside, solution exists. Okay, so considering this, guys, have a look, and I would like you to so post your answers in the description box anywhere, or give it a practice. Try this and let me know. So till then, take care. And I think that is enough math algebra for today. Okay, so let's stop here and see you next time. Okay, if you know any other methods, suggestions, let me know also. Okay, till then, bye bye.